All right, this is the review of the 2004 free response questions from the AP Calc exam. So if we look at question number 1, we have the traffic flow is given by some rate defined below, and for part A, determine to the nearest whole number how many cars pass through the intersection over a 30-minute period. So what we're going to do is start with integrating the function f of t. So we're going to integrate from 0 to 30 ft dt, and because this is the calculated part of the question, I'm not going to worry about actually like evaluating anything. I'm just going to use the calculator. So we show that work there, and then we go over to our calculator, and I already have the function put in here. And then all I need to do is menu, calculus, numerical integral from 0 to 30. Of f of t and dt, and it's going to give me 2474.08. So that's going to be 2474, and then we need units. That's going to be cars. So this is a 3-point question. You're going to get 1 point for the limits of integration, a 2nd point for the actual integral, and then a 3rd point for the solution. All right, and then moving on to part B. Is the traffic flow increasing or decreasing at t equals 7? So the way we determine if it's increasing or decreasing is by finding the rate of change. So that would be f prime f prime of t is going to give me the rate, and to determine if it's increasing or decreasing, I'm going to check for greater than or less than 0. So basically all I need to do is evaluate f prime of 7, and again I'm going to use my calculator. I already have the function put in there, so I'm going to do menu, calculus, numerical derivative. We can make the variable whatever we want. I'm going to call it t. The value is 7. We're going to hit OK, and it's going to be f of t. And it's going to give me negative 1.873. And that is less than 0. So what does that tell me? It tells me that it's decreasing. So we would simply just have to say traffic flow is decreasing because f prime of 7 is less than 0. And that's going to be just 1 point, and that's just going to be for the answer with the description. Part C, what is the average value of the traffic flow over the time interval 10 to 15? Indicate units of measure. So we know the average value is 1 over the bounds. The bounds happen to be 10 to 15. So it's 1 over 15 minus 10, which is 5 times the integral itself. Again, that's just a calculator question straight away. So it's going to be 1/5 of the numerical integral from 10 to 15 of f of t dt. And we get 81.899. 81.899. We need the units of measure because it specifically says include the units of measure. This is an average value. So if we're looking what our units up here, we have cars per minute in minutes. So the average value is 81.899 cars per minute. That's my final answer for part C, and that is a 3-point question again. A point for the limits of integration, a point for the integrand, including the dt, and then a point for the solution with the correct units. I need to point out as well that back on part A, you needed to have the ft and dt in order to get your full points. Alright, and then the last part, part D. What is the average rate of change of the traffic flow over the time interval between 10 and 15 minutes? So average rate of change, remember average rate of change is different from average value. Average rate of change is just the slope. So it's going to be f of 15 minus f of 10 over 15 minus 10. And again, I can use the calculator. And I'm going to plug it in exactly the way it's asking me to. I'm going to get a fraction there. It's going to be f of 15 minus f of 10 over 15 minus 10, and I get 1.518. And we need units again. That is, the units of measure for the original function was cars per minute. So this is 1.518 cars per minute, and it's a rate. It's the rate of change of that rate. So it's cars per minute squared. And that's my final answer there. And that's going to be my final 2 points. And that's going to be it for question number 1. Alright, so question number 2. Let f and g be the functions that are shown in the picture, and they're defined down below from 0 to 1. The graphs of f and g, like I said, are already shown. Find the area of the shaded region enclosed by the graph of f and g. So we know that the area of a region is the integral given the bounds, which in this case the bounds are 0 to 1, and it's going to be the top function minus the bottom function. So the top function is f of x, and the bottom function is g of x, and we're integrating with respect to x, so we have d of x. So that's pretty straightforward. Again, this is a calculator problem. So I'm just going to go to the calculator real quick. Alright, so on the calculator I have the two functions defined. Menu, calculus, numerical integral, bounds are 0 to 1. And I'm going to have f of x minus g of x with respect to x. And I get 1.133. And there are no units, so it's just 1.133 is my final answer. This is a 2-point problem right there. Part B, find the volume of the solid generated when the shaded region enclosed by the graph of f and g is revolved around the horizontal line y equals 2. So here's what we're going to have to do. We're going to have to think about where is the line y equals 2. So 1's up here, so 1's right there. 2 is going to be up here somewhere. So we have this imaginary line here where both of those functions are revolved. So we have this giant picture, if we can kind of like zoom out. So imagine that this was our graph like that. Here's 2 up here. We're 2 units away, so we're even further up here. We're going to have this picture. That looks something like that. So we have this inside disk and the outside disk with a big hole in between. Like the shaded stuff is going to be the big hole. So it's revolved around that line y equals 2. So we have two functions. We have the outside function, the outside radius, which is the distance from 2 to the outside of the curve. and then we have the inside radius, which is the distance from 2 to the inside of the curve, or the inside curve. So when we integrate this, we know that the volume of any rotated object is pi times the integral from 0 to 1. Those are our bounds in this case. And my big curve, my outside curve, is the distance from 2 all the way down to the outside curve G. That's going to be big R. And then little r is the distance from 2 to my f function. So my volume here is going to be 2 minus g of x squared minus 2 minus f of x squared with respect to x. And then from there, again, it's a calculator problem. So I'm going to go to my calculator. And I'm going to start with pi. Now let's get that pi back real quick. So pi, and then we have the integral, numerical integral from 0 to 1 of 2 minus g of x squared minus 2 minus f of x squared, and we're taking that with respect to x. And that leaves me with 16.179. So 16.179, and we don't have units once again, so that's my final answer. This is a 4-point question. You're going to get a point for the limits and the constant, so both things. You're going to get 2 points for setting up the integral appropriately with the dx, and then you're going to get 1 point for your final volume. And then there's a note in the scoring guide. If you're missing, or if you're not in this form of r squared minus r squared like that, you're going to miss out on 2 points. So the best you can get is 2 out of 4. Alright, then part C. Let h be the function kx times 1 minus x for 0 to 1 for each k greater than 0. The region enclosed by the graphs of h and g is the base of a solid with square sections perpendicular to the x-axis. There is a value of k for which the volume of the solid is equal to 15. Write but do not solve an equation involving an integral expression that could be used to find the value of k. So the important thing to remember here is that if the problem gives you the base, it gives you the shape that the base is. So in this case, it tells me that the base is a square. That means the volume of that shape is just the integral of the area of that base squared. The area of the base squared. That's going to be the volume every single time. If it gives you the shape of the base, the volume is going to be the integral of the area of that shape squared with respect to whatever variable. So in our particular case, our volume is the integral from 0 to 1 of, well, let's see. So it says enclosed by the graphs of h and g is the base of a solid with square cross section perpendicular to the x-axis. Well, we're going to have the square is just the side lengths. So we have two side lengths. We have the h and the g. So if we picture, so we have g already on here, so this is g. And then h is some other function, which we don't know. We just know it's kx times 1 minus x. So it's going to look similar to the f function, so maybe it looks like this. But the base is going to be whatever shape we get from that. So like whatever height that is, then we're going to extend that into the page and we get like the square shape. Well, how do we get that height? Well, that height is this distance plus that distance. So it's this height plus that height. Well, since the g function is underneath the curve, it's already a negative, so we have to account for that by making another negative. So it's going to be the h function, h of x, minus g of x. And the reason why it's minus, normally we'd be adding them together, but it's minus because it's underneath the curve, so it's already negative, so we need to make it back a positive. And then we're going to square that whole thing and take the integral with respect to x. Now it says there's a value k for which the volume of the solid is equal to 15. Write but do not solve an equation involving the integral expression that we used to find the value of k. So we're not quite there because I don't see a k in here. All we're going to do from this point though is plug in what we know. We know that the volume is equal to the integral from 0 to 1 of, what's our h function? Well, h was defined as kx times 1 minus x minus, put that in a big bracket, minus our g of x function, which the g function was 3 times x minus 1 times the square root of x. And that's all with respect to dx. And the whole thing is equal to 15. This right here is what they're looking for. That function. Here's my g of x function. Here's my h of x function. Here's my g of x function. We're subtracting them. And then don't forget that we also have to square it. And that's equal to 15. And that's it for question number 2. Alright, number 3. So we're told that a particle is moving along the y-axis, so that its velocity is given by v of t equals 1 minus tan to the negative 1, or arctan of e of t. At time 0, the particle is at negative 1. Find the acceleration of the particle at 2 seconds. So we know that acceleration at 2 seconds is equal to the derivative of the velocity at 2 seconds. That's a calculator question. So once again, go to my calculator. There's my velocity function. I'm going to evaluate it. Calculus, numerical derivative. I'm going to change that to t. We could leave it as x if we wanted to. It's at 2 seconds. And it's v of t. And I get negative 0.133. Negative 0.133 something. We don't have units, so that's going to be my final answer. That's just a 1-point question. Remember, this is the calculator part. They expect you to be able to have that done quickly. Is the speed of the particle increasing or decreasing? Well, I know the acceleration. I know the acceleration at 2 seconds, but I don't know the velocity at 2 seconds. So I'm going to very quickly evaluate the velocity at 2 seconds. So I'm going to evaluate v of 2, and I'm going to get negative 0.436. So what do we see here? So we know that a of 2 is less than 0. So since a of 2 is less than 0, and v of 2 is less than 0, so the velocity is negative, so it's moving backwards, but it has a negative acceleration, so that means that it's moving backwards, but it's going slower backwards. So it's starting to slow down going backwards. So is the speed increasing or decreasing? So if it's moving backwards, but it's slowing down backwards, it's actually moving, it's actually speeding up because both of them are negative. So since a of 2 is less than 0 and v of 2 is less than 0, the speed is increasing. And the key word here is that it's speed, not velocity. Remember, speed is velocity is the speed with a direction. So speed is just which way is it going, or speed is just how fast is it going. I don't care which direction it's moving. Part C, find the time greater than 0 at which the particle reaches its highest point. Justify your answer. So normally what we would do when we talk about highest point, maximum, minimum, we're thinking about taking the derivative. But in this case, because we're given a velocity function, we don't have to do that. We can just look at the velocity function itself. So we're looking for where is the velocity equal to 0. And if you do some quick algebra, that's going to happen when arctan of e to the t is equal to 1. So if you take the tangent of both sides, e to the t is equal to tan 1, so the natural log of the tangent of 1 is equal to t. So t equals 0.443. Alright, so that's possible critical value, but at highest point implies absolute max. So that means we need to check our bounds as well. But the only bound I have is 0. So I need to check two things. I need to check what's happening at 0, what's happening at 0.443, and then what's happening beyond 0.443. So if we check 0.443 and then beyond, we know that this is 0 here. What's happening between 0 and 0.443? Well, I can check my velocity in between those 2 points. I know that this is going to be negative outside because part B, we already found out that v of 2 was a negative value. So we have to be positive in between. So if we look at this, we're going from positive to negative, so that means that 0.443 has to be a maximum. So maximum at t equals 0.443 seconds because v of t is greater than 0 when t is between and v of t is less than 0 when t is greater than 0.443. So that would be our justification right there. I missed the point values on the other two parts. Part B is 1 point and this is 3 points. You're getting a point for setting v of t equal to 0, showing that 0.443 is a possible highest point, and then a point for y, it's your maximum value. Okay. Part D, find the position of the particle at 2 seconds. Is the particle moving toward the origin or away from the origin at 2 seconds? So how do we find the position of a particle? Well, that's the integral. So it's some function y of t because we're moving along the y-axis. We need to remember where we started, so we need to go back and look at our initial information. At time 0, the particle is at -1. So we're starting at -1, and then we're adding the integral of the velocity, which the integral of the velocity is going to be the integral of 1 minus the inverse tangent of e to the t dt. And we want to know what's happening at 2 seconds, so we're going to integrate that from 0 to 2. So we can go ahead and change that y of t to just y of 2. And now we can go ahead and evaluate that using our calculator. get this switched back over to the calculator real quick. So we have -1 plus the integral from 0 to 2 of v of t dt, and I get -1.361 if I round that. Find the position of the particle at t equals 2, so there's my position, okay? And then, is the particle moving toward the origin or away from the origin at 2 seconds? Justify your answer. So it's moving away for 2 reasons. Moving away from the origin because, well, why is it moving away? It's moving away because y of 2 is less than 0, and also, so y of 2 is less than 0 means it's left of the origin, but that doesn't tell me if it's moving towards it or away. We have to also look at the velocity. Well, we already know that the velocity at 2 seconds was also less than 0, so it's moving left, or it has a position that's left of the origin from this statement, so it's positioned left of the origin, and the velocity is negative, so it's moving further left of the origin. So it's left and it's going further left, so that tells us that it's moving away from the origin altogether. And this is a 4-point problem. You're getting 1 point for just this integral. You're getting a point for that initial condition that we started at -1. You're getting 2 points for that solution right there, and then a final point for deciding if you're moving towards or away from the origin. And that's going to do it for the calculator part of the free response questions, and then we'll make another video for the non-calculator part, questions 4, 5, and 6.